Okay, so today we're looking at still chapter 11. This is lesson 3, but we're looking at integration by substitution now. This is the technique that the majority of people use to do integration substitution. And it's where you're basically replacing a part of the expression to make it easier to integrate, and then putting it back in towards the end. So let's have a little look at this one here. So here we've got use the substitution. U is equal to 2x plus 5 to find the integration of x root 2x plus 5. So using the substitution, work out x and dx, or the variance. So the first thing that we need to do is we need to differentiate this value here. So always what we do is we differentiate this value here to find out what dx is. Okay, you'll see what I mean by this in a little second. So first of all, this one here is example 1. Now I'll talk you through this, and as we do more, it will become more apparent what I'm doing. So the first thing I'm going to do, I'm going to differentiate this with respect to x. So let's just write this here. U is equal to 2x plus 5. So in which case, if I'm differentiating this with respect to x, du by dx is equal to 2. Brilliant. Now the whole point of this, the reason that we're differentiating this, is because we're trying to find out our replacement for this part here. Okay, we're trying to find the replacement for dx. Okay, so what I then do is I rearrange this to find out what dx is. So I'm going to bring the 2 down and bring the dx up. So du divided by 2 is equal to dx. Okay. There we go. So we found out what dx is. The next thing we need to do is to find out what the only other part that we don't know. So we know that, let me just highlight here. We know that this here is equal to u. We know that dx is equal to this part here, du over 2. The only part that we don't know is what this x is. But we can actually find out what that is, and we find out what that part is by rearranging this here as well. So we've differentiated this, but we also need to rearrange it to find out what x is as well. So let's do that. So I'll do that down here. So minus the 5, divide by the 2. So let's minus the 5 first. So u minus 5 is equal to 2x. And then just draw a line here so we know these are separate, and then divide by 2. Now I'm going to divide by 2 separately for both of these. So this means that x is equal to u divided by 2 minus 5 over 2. Okay, so there's our first step. Okay, so the whole point is they've given you a substitution and you're replacing every single term with x in that integral to be u. So let's now substitute into this part here. Okay, we're substituting into this. Now we know that x is equal to u over 2 minus 5 over 2. So it's going to be, so at the moment we've got this. Let's just write it first of all so we can see. So when we substitute into this expression, it's going to be the integral of u, which is u over 2 minus 5 over 2, close that bracket, times by the root of 2x plus 5. Well, I know that the root of 2x plus 5 is equal to u, so that's going to be root u there. And then I'm going to replace this dx with the differential over here, which is going to be du over 2. So I've substituted and I've replaced all of those terms there so that it's now in terms of u. Now I probably would also write this u as a power of half. So I'm going to just do that quickly. So u over 2 minus 5 over 2 times by u to the power of a half du over 2. The next thing we need to do is to simplify this. So I probably would, you always want the du on its own on the right. Okay, you always want that. So the next thing that I need to do is I need to, we need to expand out this bracket, and we need to times by that over 2. So I'd probably at this stage even write this as u to the power of a half over 2. Now you can do this all in one step. I'm not going to do that, just to make life a little bit easier, just to make it clearer to us. So I'm going to write this as u to the power of a half over 2 du, just to kind of give us that extra step. Then I'm going to expand this out, so it's going to be the integral of u times by u to the half is going to be u to the 3 over 2 over 4, 2 times 2, minus 5u to the power of half all over 2 du. Okay? So you can see that I've used substitution to turn this equation into something that I can integrate. Okay? And we can integrate these by raising the power and dividing by that. Okay? So let's have a look at this then. So now let's actually integrate it. Well, u to the power of 3 over 2 is going to be u to the power of 5 over 2 over 4, well then times that by the reciprocal of this, so times by 2 over 5, or you could say divide by 5 over 2, minus 5u to the power of 3 over 2, raise the power, and then times by, divide by the power, or times by the reciprocal, so times by 2 over 3, not forgetting plus c. Then I'm going to simplify this. So the 2 will cancel there to become 2 on the bottom. That 2 will cancel there. Is that all I can simplify? I think it is. So I end up with this being equal to u to the power of 5 over 2 all over 10 minus 5u to the power of 3 over 2 all over 3 plus c. Now you've not finished there, because this is in terms of u. And actually what I want is the integral of this in terms of x. So the last little part, which is step 4 on here, is to write your answer in terms of x. So basically what I'm doing is I'm substituting that u back in to replace this now for x. So I end up with, well, I know that u, I'll just write it here to make it really clear. I know that u is equal to 2x plus 5, don't I? So then my final little stage here is to substitute all this back in. So it's going to be 2x plus 5 all to the power of 5 over 2, all divided by 10. So you have replaced that u with x plus 2x plus 5, minus 5 times by 2x plus 5 to the power of 3 over 2, all divided by 3 plus c. Brilliant. I'll give you a second to get that down. I'm just going to check my answers right as well. What my mistake have made there? There's my mistake. So I have made a little tiny mistake here, and it is for this part here. When I expanded this out here, 2 times by 2 should be 5 over 2. Sorry, 5 over 4. So this is going to be, this is over 6 here. Like so. All right. So there's our first there's our first question on substitution. Now, it seems tricky at this stage, but to be honest, I actually think this is the easiest option for integration. And when you do a lot of integration questions, this technique becomes a lot simpler. So just to kind of summarize, they don't always give you the substitution. Sometimes you need to work that out, but I'll talk about that in a second. You replace everything in your expression or your integral in terms of x by either differentiating or substituting directly in or rearranging. Okay, that's what we did in step 1. We then need to simplify so it's easier. Okay, and then we do our integration but write it back in terms of x. All right, super. Let's have a go at our next question then. Let's have a go at our next question. So there's the answer. So this is just thinking about what a sensible substitution would be. Okay, so thinking about what a sensible substitution would be. So the whole point is you want to try and get rid of anything which is inside a function. So here, going on to this one here, I think the best possible option here for the substitution is to replace this part here. Now take note, you could use the reverse chain rule for this if you wanted to. Alright, so our function is that root, and inside that function is the 1 plus sine. So our replacement here is going to be u is equal to 1 plus sine of x. In this one here, we've got 6x e to the x squared. Now our function is that e. So inside that function here, we've got the x squared. And this is what we're going to be using as a substitution. Like so. Now, this next one here is tricky actually, because the problem we've got is with that e to the x. So why is that e to the x there? But that's not actually in what we want. The thing that we want is this part here. This is the substitution we're going to use. We're going to use what's on the bottom here. We'll talk about one similar to that later on, but just to make it really clear, it's because we're dividing by there, and that's the function. So here we're using 1 plus x. And we'll talk about that one in a little bit. I think that's probably the hardest one to spot. And here for this next one, we're going to be using the power here. And again, we'll talk about some of these in a second. So it says at the top there, in Excel you're usually given the substitution, however in some examples and in STEP you're often not. Now, the other kind of side to that is that sometimes you can actually use the reverse chain rule, but it's easier to use substitution. So you might want to use substitution, then in that case they might not give you the substitution, if that makes sense. So I think it's always important to kind of know what a sensible solution is for this, even if you're not doing STEP and even if you're not doing other exam boards, because there will be integrations that come up where you can use substitution, but it doesn't tell you what that substitution is. Not always the case. All right. Oh, that isn't 4x. That is x plus 1x. It's just that the 1 and the plus looks like it's joined. So I just changed that. I think it was just my handwriting. 1 plus. The 1 plus looked like it was joined like that. So it looked like 4. Sorry. Okay, so let's have a look now at some of these questions. So here's a common question. Using the substitution, u is equal to sine of x plus 1, find the integral of cos x sine x times by 1 plus sine x cubed. So the first thing that we need to do with this is we need to think about all those things I said. We're going to replace everything in there, aren't we? Okay, so let's start off with u. Now you notice that the u is this part inside here. u is equal to sine of x plus 1. Brilliant. I also need to differentiate this to get rid of that, to find that dx. So if I differentiate this, it's going to be du by dx, differentiate this with respect to x, is equal to, well, what does sine differentiate to? Sine, cos, minus sine, minus cos. Sine differentiates to cos. 1 differentiates to nothing. So this is going to be cos of x. But remember, we want what dx is, so that we're going to bring the cos x down, and we're going to move that dx up. So we're going to end up with du over cos of x is equal to dx, like so. Brilliant. Now, I'll talk to you a little bit about this in a second. You might kind of panic about this cos inside of here, but actually we don't need to worry about that cos inside of there because they will cancel later on. The only thing we do need to worry about is rearranging this to be equal to sine. So if I rearrange this to be equal to sine, it's going to be sine of x is equal to u minus 1. And you'll see how they all fit in a second. So the things that I've replaced are, I'm going to highlight them just to make it really clear. I've replaced the sine here with that there. I'm replacing the 1 plus sine x with u, which is already up here, like so. And I'm replacing the dx with du over cos x. Now you might think to yourself, well, how do I... so I'm replacing this here with the du over cos x. Now you might say the only thing that's not highlighted there is cos, but we'll see that cancel later on. Okay, so that's our first part. The next thing we need to do is then to substitute in for everything you've got. Now, you should find this pretty easy now. So it's the integral, I'm going to write it down first, of cos x sine of x times by 1 plus sine of x all cubed. With respect to x, sorry, that's really important, isn't it? So if I replace this, it's going to be the integral. Now, the only thing I don't have is that cos x, so let's keep that there. Cos of x. I know what sine of x is. It's the yellow one, isn't it? Which is going to be u minus 1, so times by u minus 1, times by the 1 plus sine x is the blue part, which is just equal to u, so that's going to be u cubed, like so. And then the dx is the green part, which is du over cos of x. Now, at this stage here, you can see that the cos x actually cancels. So we didn't need to worry about that one there because it cancels there like so. And all you're left with is the integral, and I'm going to just expand it straight out, the integral of u to the power of 4 minus u to the power of 3 du. So I've expanded out there, the u to the power of 3 times by u is u to the power of 4, u to the power of 3 times by minus 1 is u to the power of 3, and it's left me with this integral here, which is really straightforward to work out. So this is going to be u to the power of 5 over 5 minus u to the power of 3 over u to the power of 4 over 4 plus c. Now remember, we know what u is. Okay, we know that u is equal to sine of x, so I can just replace this last thing of all. So sine of x plus 1 all to the power of 5 all over 5 all over 5 minus sine of x plus 1 to the power of 4 all over 4 plus c. Brilliant. I'll give you a little second to get that down. So let's move on then. So we've got one more to have a little go at. I think you probably could do this yourself now. However, I'm not going to ask you to do that just yet. I am going to go through this one as well, and then we'll, I think there's actually, yeah, and then there's a question for you to have a little go at yourself. Okay, so this now is different because it's a different substitution and it's using implicit differentiation. Now, you wouldn't be expected to know this substitution. However, actually, it does make things a little bit easier. So, let's have a look now. Using the substitution, u squared plus 2x plus 5, find the integral of this. So, let's have a go at this. Now, we know, is that the same as the one before? I think it was the same as the one before. So, we already know what the integral of this is, but we're going to do it anyway. So, the first thing I would probably do, u squared is equal to 2x plus 5. I'm just going to check if that one's the same. Is that the same as the first one we did? It is, yes. So we already know what the answer for this is, but it just kind of shows that you don't always have to use the correct substitution. Oh, sorry. We can use different substitutions to find out our values. But anyway, we'll carry on with this. So this differentiates to, now if I'm using the chain rule on this, it's going to be, we're differentiating with respect to x. So I need to differentiate u in terms of x. So it's very similar to when we're differentiating y squared. And this is going to be 2u, which is bringing the 2 down and there like so. But then I need to differentiate inside this, which is going to be du by dx, which is equal to 2. Okay, because 2x differentiated with respect to x is equal to 2. 5 differentiated with respect to x is equal to nothing. Okay, the hard part there is knowing to differentiate, how to differentiate that 2u, and you differentiate it in a very similar way you differentiate y squared. So there's our first little step. The other thing which is important is we need to get rid of do I need to get rid of the x just yet? I'm pausing for this for a reason. Sorry, we do also need to make sure that we're rearranging this, don't we? So what we're trying to find dx. So let's bring the 2 up, and in fact we can cancel those 2 there, can't we? So cancel the 2 from both sides. Oh, in fact, let's bring the 2 up first. 2u du is equal to 2 dx. Now I can cancel the 2's from both sides, and I'm just left with dx is equal to u du. Well, don't forget that u is this over here. Okay? Don't forget that u is equal to that. Alright? So, do I need to rearrange this to find x? I don't think you actually do need to do that, to be honest. Oh no, so you don't need to rearrange to find u itself, but you might need to rearrange to find x. Let's just do that one here. So if I rearrange to find x, it's going to be u squared minus 5 is equal to 2x. And when I differentiate this, I'm going to do this separately. So u squared all over 2 minus 5 over 2 is equal to x. Okay, brilliant. So we've got some of our substitutions now. We know that this part here is this part here. We know what dx is. I should have put dx over here. I made a mistake there. This here should be dx is equal to that. Okay. Yeah, so we know that the 2x plus 5 is equal to this part here. We know that the dx, so this dx is equal to this part here. That's fine. We don't know the x, but we'll think about that. Oh no, we do know what the x is. The x is this part here, isn't it, actually? We have actually worked out what x is, so that is fine. Okay, so let's substitute in. So I've got the integral of x root 2x plus 5 with respect to x. Let's substitute all those values in. So it's going to be the integral of x, which is u squared all over 2 minus 5 over 2. That's for x. That's what I've just replaced the green part. Times by the root of this. So it's going to be the root of that yellow part, which I actually know is u squared. And dx I know is u times by du. Brilliant. So let's then simplify this. Now, the root of u squared is just going to be equal to u. So this is going to be the integral of u cubed over 2 minus 5u over... I'm going to change that actually, because I've actually got... I'll do the outside of the bracket first and then I'll talk about it in a second. So, u du. I've actually forgot about this u outside here, so let's do that first of all. The integral of u squared all over 2 minus 5 over 2. Let's just times these two things here together. So the root u squared and u, let's times both of those together. Okay, and if I times both of those together, I end up with u squared du. And then what I'm going to do is now I'm going to expand this out. So it's going to be the integral of u to the 4 over 2 minus 5u squared over 2 there, like so, with respect to u. Okay, now I can integrate this. Let's just write it down here. So I've got it, u to the power of 4 all over 2 minus 5u squared over 2 du. So if I integrate this, it's equal to u to the power of 5 over 10 minus 5u to the power of 3 over 6. Okay. Plus the c. Now the only thing that I need to do now is to replace that u to make it in terms of x. Now this is what I was talking about before when I was talking about replacing x actually. I was thinking about the end. And u is equal to the square root of 2x plus 5, or we can write this as 2x plus 5 all to the power of a half, like so. I'm going to write it as a half because I actually know it makes it a little bit easier when you're expanding out. So it's going to be 2x, I'm going to just make it nice and clear, to the power of a half, all to the power of 5 over 10. Minus 5 times by 2x plus 5. Now, you could have just done this all in one. I've decided not to do that, just to show that I'm directly replacing this. Here, 3 all over 6 plus c, which gives you your equation here, which is exactly the same as the one before, isn't it? 2x plus 5 all to the power of 5 over 2 divided by 10 minus 5 times 2x plus 5 all to the power of 3 over 2 all over 6 plus c. Brilliant. Which is the same as what it was before. Absolutely absolutely brilliant. Super. Cool. So, here's a little test your understanding question. So they've given you the substitution. Alright. Have a little go at that one yourself. Have a little go at that one yourself there. Super. All right, sorry if that was muted. All right, so hopefully you got that down. So have a little go at this question yourself. Now, just in case you missed that, if you were muted, just to let you know, the thing that we've done is that we have changed the boundaries for x. The problem is that our boundaries, so between 0 and pi over 2, are currently in terms of x, but actually we want them in terms of u, and we do that by substituting them into our substitution. So we're substituting these values into this here to find out what they are in terms of u, because at the moment they're in terms of x. Okay, that's the only difference really. All right, so here's a question. Have a little go at that question yourself. Have a little go at that question yourself. Now, just to point out with this question that they're not actually asking you to integrate it, they're asking you to prove that it's equal to that, because you don't actually know how to do this integration just yet. We're going to be looking at that next. So just, can you get to this stage here? Alright, so let's have a little go at this one here then. So we've got y is equal to x to the power of 3 ln of x squared plus 2 there, like so. And it's saying use the substitution u is equal to x squared plus 2. So we know that we're going to differentiate this first. So du by dx is equal to 2x, which gives me du is equal to, du over 2x is equal to dx. Brilliant. Okay. Do I need to find a replacement for x as well? No, I do need a replacement for x squared. You'll see why for that in a second. Hopefully you should be able to see that. When I replace the dx, the x on the bottom and the x cubed are going to cancel, and it's going to leave me with x squared. So actually what I do want is u minus 2 is equal to x squared. And we'll talk about that in a second if you don't know what I'm talking about. Okay, so here's our replacement. Now, we also, very tricky. Now notice that our limits here are in terms of x, and actually we want these limits in terms of u. So we need to substitute these into our substitution. As I was getting confused. So substitute these into our substitution. So at the moment we've got u is equal to x squared plus 2, and we know that x is equal to 0 and also x is equal to root 2. So u is going to be equal to 0 squared plus 2, which is equal to 2, and u is equal to root 2 all squared plus 2, which is equal to 4. So there are two limits, 2 and 4. Brilliant. So now we can substitute everything into this, can't we? So we're going to do the integral between 2 and 4 of, now I'm not going to replace that x cubed yet, x cubed ln of x squared plus 2 is equal to u, there, like so. With respect to, this should be with respect to x, so this is going to be, with respect to x is going to be du over 2x. So the x's will cancel here, like so. That should be cubed, shouldn't it? So the x's will cancel here, so that is going to be squared, that is going to cancel. I end up with the integral between 2 and 4 of x squared ln of u with respect to u. Now notice this is what I said before. I said that because those x's cancel, this is all over 2. Take that half out, can't I? Because those x's cancel, I'm just left with here x squared, and that's what my replacement there was, wasn't it? So this is going to be equal to, let's take that half out, a half integral between 4 and 2 of x squared, which is u minus 2 ln of u du. There we go. And that's what they're looking for. Super. Now we're going to look at the way we can integrate this in a second. In the next part, which is going to be integration by parts. Okay, so get that down there.